Hello, my name is Zach Gibbs, and I'm a content developer within education services inside Juniper Networks. And today we will be going through the segment routing basic traffic engineering learning byte. Alright, so here is our example, and in this example there's a few things I want to point out. Let's look at the topology first. And in the topology we have two customer edge devices. We have user 1 that is connected to CE1, and then we have server 2, which is connected to CE3. And CE1 connects into R1, which is the PE router for CE1, and CE3 connects into R4, which is the PE router for CE3. So in the provider core, we have R1, R2, R3, R4, and R5. And notice how each of them are connected. R1 is connected to R2 and R3. Then R2, which is connected to R1, is also connected to R3 and R5. Then R3, which is connected to R1, is also connected to R2 and R4. And then R5 has two connections, R2 and R4. So with this topology, we have ISIS configured as the IGP, and we have segment routing is configured and working, but it's only working in the aspect of traffic is following the shortest path. So with user 1, right now, traffic being sent to server 2, it's going to be going to R1, then to R3, then R4 to get to CE3. And we want to change that up a bit. With user 1, traffic from user 1 to server 2, we want that to start at R1, then go to R2, then to R5, and then to R4 before it's forwarded to CE3. And we can use traffic engineering to do this. So with that, let's go ahead and jump to the CLI and get this going. So here is the CLI, and we have a few different devices we will be working with. We have R1, R2, R3, R4, and R5. Now, R5 is a little special. R5 is actually a logical system on R2, and so that's why you see in the hostname here, R2:R5, because I set the CLI to the logical system of R5 with this session here. So that's why you're seeing that, and for all intents and purposes, R5 is a separate node because it's a separate logical system with its own interfaces and protocols and everything. And then we have the VR device, which contains the CE devices as well as the user 1 and server 2 devices. And we'll be using this VR device to send traffic between user 1 and user 2. So to begin, let's go ahead and start traffic flowing between user 1 and server 2. The server 2 address is 10.105.1.100. We're going to source it from the routing instance, user 1. We can see traffic is flowing there, and that's perfect. So let's go ahead and jump to R1 and look at a few things. So to begin, let's look at that route for server 2. And we can see that here we are sending traffic. We're sending it through the Gigi000 interface, and we're pushing labels 63 and 5004. Now, the thing I want to point out here is that each device in the network, each provider device, has a label assigned to it, a node segment label. And R1 is 5001, R2 is 5002, R3 is 5003, R4 is 5004, and R5 is 5005. And so you can see here that we're pushing 5004 on top, which is the node segment label for R4, which is a label for a VPN route. So first, let's look at the ISIS adjacency. And we can see with Gigi000, that's going towards R3. Now, that's not what we really want to do. Even though traffic is flowing, we want to send it from R1 to R2 to R5 to R4. We want to take that alternate path, which is not following the IGP shortest path. This right here is going to be following the IGP shortest path of R1, R3, R4. And so let's jump into configuration mode and get this going. Go to source packet routing, and we need to set up the source routing path. We're going to say 2-R4. And then we're going to specify the loopback address of R4. And then we're going to set a primary path called lb-path. Now, this primary path isn't configured yet because we need to configure that. And we can see here, we do a show. It says the segment list reference isn't there. And so we need to configure that segment list. And in the segment list, we know we want to send it to R2. So let's set the hop. We're going to call the hop H1, and we're going to specify a label of 5002. And now that's the label of R2, of course. So it's pretty straightforward, just one hop specified. Let's commit that. Okay, that's committed. Now let's check to see if traffic is still flowing. And now that's not a good sign. Traffic is not flowing between user 1 and server 2. So let's go ahead and jump back to R1, and let's look at things. Let's look at that route. And it helps if I specify the right IP address. Okay, so we can see it's using a different interface, Gigi001, and it's pushing label 63. And we look, Gigi001 is R2. Okay, so good, we're pushing it to R2, but I have a feeling that since we're just pushing label 63, R2 doesn't know what to do with label 63. When we look at label 63, yeah, it's got nothing in there. That's going to be in R4 because that's the route or the label associated with the VPN route. So let's go back to R1. We obviously need to make some changes to the path. And what we can do here is we can set another hop. We're going to call this H2, short for hop 2, of 5004. And that's going to be the label for R4. Let's commit that and see what happens. Let's look at the traffic, and traffic's flowing again. Great. So let's look at the actual path. And we can see here, okay, we're still using Gigi001. That's going towards R2, perfect. And then we're pushing labels 63 and 5004. So 5004 is on top, so that's the label that R2 is going to look at. So let's look at 5004. We can see here that 5004 is being swapped for 5004, so R2 does do something with that, and it's using Gigi004 for the interface. When we look at that, we see Gigi004 is going towards R3. That's not good. It should be using Gigi005, or at least that's what we want it to use. Notice how under Gigi005 it shows R2-R5. And that's because that's a logical system on R2, but that is actually R5 for Gigi5. So we want to get it to go out Gigi005. So although traffic is flowing, it's not flowing the correct path or the path that we want it to flow. So let's go back to R1. We can see here we have the two hops, and we need to specify different hops. So get to R2, we want to send it to R5. So to do that, let's create another hop. We'll call this H1.5, label 5005, and we want to insert H1.5 before H2. We see here we have H1 going to 5002, H1.5 going to 5005, then H2 going to 5004. Let's commit that. Right, let's make sure the traffic is still flowing. Okay, good. Traffic's definitely still flowing. Let's go back here and look at the path for that route. And we can see there's some changes here. We have 63, 5004, and then 5005 on top. So we are still using Gigi001, which goes towards R2. And if we look at R2, what does R2 show for the label of 5005? And we can see, okay, it's going out the Gigi005 interface. And recall, that is for the R5 router. And we're doing a pop, so it sees 5005, it pops the label and sends it out Gigi005. Perfect. So we need to see what label 5004 shows here. And we can see that we are popping that and sending it out Gigi007. We look at the IS-IS adjacency, we can see Gigi007 goes to R4. Perfect. So looking at R4, label 63 again, we're popping that and sending it out the Gigi007 interface. So that brings us to the end of this Learning Byte. So as always, thanks for watching.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.